The most visible change was a new and larger portrait set off center. But turning the new designs into actual money was an enormous undertaking. It began in this attic studio at the Bureau of Engraving. Engraver Will Fleischl transfers a wax outline of the new Lincoln portrait onto a clean piece of 1/4-inch steel. Next, he'll begin to cut that design into the plate by hand. No cut can be deeper than the thickness of a human hair.
It's hard to even see the lines that I engrave without a 6-power to 10-power glass, and that's purposefully done.
The minute details make the portrait harder to copy accurately, but they also make the engraver's job harder.
You have to learn to control your breathing. You have to get used to looking under magnification for long periods of time.
Perhaps the biggest challenge facing the engraver is working in reverse.
Drawing in reverse is kind of a conundrum. I mean, you have to trick yourself all the time.
It can take up to 8 months to complete a single portrait.
I enjoy watching the image develop. This was a great man, but at the same time, he had a really raucous sense of humor. He was the kind of a guy that you could talk to. I try to convey that.
The use of portraits on the face of the currency is actually done for a security reason. People are used to looking at people's faces, and they can notice a lot of detail. They can notice differences, so that if someone else tries to reproduce that Ben Franklin and doesn't do quite as good a job, you'll notice that.
Another new security feature is much harder to notice. It's called microprinting. Some engraved letters are just 1/100th of an inch tall, much too small to be reproduced on a copier. All the letters are engraved by hand for 2 reasons.
Having a hand engraving rather than a computer-generated image gives us what we feel is not only the best image, but also
It's also for security reasons that no one single engraver ever does all the work. Once the portrait and letters are engraved, they're combined onto a single steel plate called a master die. There's one master die for the front of a bill and one for the back. It's from this master die that the printing plates will eventually be made. And that process is astonishingly complex. First, a sheet of special plastic is placed on the die. The die and the plastic are then baked together in an oven at 250 degrees Fahrenheit. That sets the design into the plastic plate. The finished plastic plate is measured to check the depth of the design impression. If it doesn't match the measurements of the engraved image, it will be rejected. The plastic plates that pass inspection are then joined into a sheet of 32. Next, the sheet is sprayed with a thin coating of silver. Then it is lowered into a vat of nickel solution that contains pieces of pure nickel, here seen in green baskets. When an electrical current passes through the vat, it slowly deposits a layer of nickel onto the silver-coated plastic. The entire process takes 22 hours. The original plastic sheet will be destroyed. The nickel sheet will be the actual plate that prints money. The printing plates are not yet finished. They must first be scrubbed with a special solution to remove the silver. Then carefully ground down by a machine to a thickness of exactly 3/100ths of an inch. Next, a coat of chrome is added to harden it. Each plate is then shaped to fit the printing press. A plate can make 32 million banknotes before wearing out, so multiple working plates are made. All these plates, of course, are extremely valuable. Changing the design of U.S. currency was only one part of the Federal Reserve's program to deter counterfeiting. The other part was changing the paper. 100 years, all U.S. currency paper has been made in Dalton, Massachusetts, at the mill owned by Crane & Company.
The message to Crane is we're interested in every conceivable new form of anti-counterfeit technology, but whatever you do, don't change the feel of the paper.
The feel of the paper comes in part from the raw materials that go into it. They're actually waste products, bits of cotton, flax, and denim.
It turns out that denim, ever since its invention by Levi Strauss, has been the cloth material that has the highest quality cotton.
Some aspects of paper making haven't changed in centuries. Bales of cotton rags are loaded into the top of a huge boiler. After the hatch has been locked down, a cleaning agent will be added and the cooking will start. The boiler is 14 feet wide and is suspended 8 feet above the ground. It's made of cast iron and holds 3.5 tons of rags. The temperature inside will rise to 280 degrees Fahrenheit. After 2.5 hours, the rags have been stripped of their natural oils. What emerges is raw cellulose. But even this is not strong enough to make good paper. The fibers must be made to interlock more tightly. To do that, the rags begin a violent journey. They're mixed with harsh chemicals, beaten into a pulp and spread out over a fine mesh screen. Much of the liquid drains through. But even when the pulp is squeezed into a heavy roll, it's still too soggy to hold together. The raw paper still contains impurities. To remove them, the whole process will be repeated. This time the vat contains bleach to drain out all color. From here, the pulp is piped into a special press that squeezes out the water under more than half a ton of pressure, then cuts the paper into sheets. At this point, the paper is similar to other fine papers. But security features will now be added that will make it like no other paper in the world. The most unusual feature is this security strip, which took scientists at Crane more than 7 years to develop. It starts as a roll of plastic 2¼ miles long. The roll is cut into strips 1/16 of an inch wide. Embedded in each strip are letters, here magnified 75 times, that spell out a bill's denomination. Another new security feature is actually centuries old. It's a shadow image known as a watermark. Making a watermark begins with a wax carving. Tom Gardner engraved the portrait of Ben Franklin for the watermark in the new $100 bill. After the model's finished, it's covered in copper, then pressed into a fine mesh screen. But creating watermarks from these images takes many more steps. We can get a sense of that process in the testing lab. The wire mesh with the image is clamped into a special container. The pulp is similar to that used for currency paper. As the liquid drains out, the fibers settle onto the surface of the screen. Fibers collect most deeply in the dents of the portrait. The pulp is then lifted onto a piece of blotting paper. The portrait sticks up highest. The pulp is quickly dried under a weighted cover. What will emerge is a faint portrait that's actually part of the paper itself.
It's a series of steps that have been practiced by paper makers for many, many years. We have simply refined it. It's a process that Crane holds as one of our prized secrets.
In fact, the actual process of inserting currency watermarks is so secret that it's done behind guarded curtains. Watermarks are inserted every 6 inches onto the currency paper. This sheet with Andrew Jackson watermarks will make 20s. But the paper is not yet ready for printing. It must first get a chemical coat so that the ink will stick to it. The paper then travels through a series of 25 dryers at 300 degrees Fahrenheit. Next comes a rigorous inspection.
We have to confirm and verify that all of the things that are in the paper, whether it's a watermark, a security thread, are all present in the very specific location where they belong in the paper.
14 different cameras now scan the paper. The laser burns a tiny hole wherever there's a defect.
One defect in the unwinding of the security thread destroys the paper potentially all the way across the full width of the paper machine.
Each finished roll weighs 4 tons and is more than 58,000 feet long, enough for 3,200,000 banknotes. But the inspection isn't over yet. If the paper's too damp, it may rot. So they weigh sample pieces. If any of the samples contains more than 6% moisture by weight, the entire roll will be turned back into pulp. The paper's temperature must also be within a specified range. The paper's strength will be tested on these 125-year-old machines, which push and pull a 2-inch paper sample. If a sample tears before it's folded 8,000 times, the entire roll will be rejected. Every roll that passes inspection is cut down into smaller rolls, then fed into a high-speed cutting machine. Each sheet can make 32 banknotes. Even at this point, an inspector can reject an entire roll. The finished sheets are stacked into blocks of 20,000.
By the time we're done with it, we have invested a great deal of know-how in converting these materials of almost zero value into the most prized and arguably the most valuable paper in the world.
In fact, the paper is so valuable that every shipment leaves the mill under armed guard. The paper arrives here at the Bureau of Engraving and Printing in Washington. Today, they're getting ready to print new $5 bills. Each printing plate gets a final inspection. The plates are bolted onto the printing cylinders 4 at a time, enough to make 128 notes per revolution. To print that much money requires 3 tons of special ink a day. The exact formulas are kept secret, but black ink is used for the front of the bills and green for the back. Once the plates are inked, the paper can be added. The fronts and backs of all currency are printed separately. The fronts are always printed after the backs, so that the portrait will stand out clearly. It's critical that the paper be lined up properly. The press operator removes any sheets that have slipped out of position. Finally, they're ready to start making money. At full speed, the presses will churn out over 268,000 bills an hour.
The United States currency is printed by the intaglio printing method. So we actually emboss the paper, forcing the paper into the engraved lines. So you have that raised feel to the print.
Before printing is complete, the bills must pass an exhaustive inspection. The inspectors first make sure the sheets don't stick to each other. Electronic sensors will scan every note. They check the placement of the security thread and the watermark. A sheet is rejected if the space between the edge and the printing is greater than 1/10 of an inch. Other sensors check the density of the ink. The sheets are flipped twice to check both sides. But even machines can make mistakes, so a technician inspects samples to catch any errors that might have slipped through. Now the sheets will move on to the final and critical stage of becoming money. Each note will be given a serial number composed of letters and digits. The serial number is a banknote's birth certificate. The number is printed in green in 2 places on the front of every note. The letters indicate the Bank of the Federal Reserve that asked for the money. In addition to the serial number, the press also prints the seal of the Federal Reserve System and that of the U.S. Treasury. The points on the Treasury seal serve a security function. They're very difficult to photocopy. For the final inspection, sample sheets get checked by 2 operators. The sheets that pass this inspection are now ready to make the final cut. $100 at a time, they're sliced into sets of 2 notes, then into individual banknotes. Hundreds of hours of labor have turned scraps of fabric and a few drops of ink into the world's most valuable currency. The finished banknotes are bundled into stacks of 100, then bound into blocks of 1,000.